A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
So, Herman, I was looking at some of the developer forums last night, and the fallout from the cursor incident is still absolutely everywhere. It is the kind of drama that really peels back the curtain on how the industry is actually operating behind the scenes. It is not just a technical glitch, it feels like a vibe shift in the entire power dynamic of global AI development.
It really is. The Cursor and Kimi leak from March 19th has effectively shattered the illusion that Western frontier models have a permanent, unbridgeable lead. For those who missed the noise, Cursor, which is widely considered the gold standard for AI-powered coding tools, was found to be using a fine-tuned version of Moonshot, AI's Kimi K2.5, for its Composer 2 feature. It only came out because of a leaked model identifier in the API responses, and then Yulun Du, who is the head of pre-training at Moonshot, basically called them out on it on social media.
It is wild because everyone just assumes these top-tier Western tools are powered by OpenAI or Anthropic. If you are paying for a premium subscription to a Silicon Valley startup, you expect Silicon Valley code under the hood. But today's prompt from Daniel is about why that assumption is becoming increasingly outdated. Daniel wants us to dive into the big four Chinese labs, DeepSeek, Moonshot, Zhipu, and MiniMax. He is asking which of these show the most promise for code and agents, how they actually stack up against the Western state-of-the-art, and if there is any reason to use them other than just saving a few bucks.
I am Herman Poppleberry, and I have been waiting for us to really dig into this because the shift we have seen in just the last few months is staggering. We are no longer talking about cheap knockoffs or cost-effective alternatives. We are talking about architectural innovations that are forcing the heavy hitters in San Francisco to look over their shoulders. As of today, March 23, 2026, the gap is not just closing. In some specific domains like long context retrieval and reasoning efficiency, it might have already disappeared.
Well, let us start with the one that seems to be the current king of the hill for developers, which is DeepSeek. They have been the talk of the town since the R1 release, but the buzz around the imminent V4 release is reaching a fever pitch. People are saying it might actually leapfrog GPT 5.3 in long context coding. What is actually under the hood there that makes them so different?
The genius of DeepSeek, led by Liang Wenfeng, really comes down to mathematical efficiency. While the major Western labs have been throwing more and more compute and more parameters at the problem, basically trying to brute force intelligence, DeepSeek has focused on architectural cleverness to bypass the need for massive hardware clusters. They use something called Multi-head Latent Attention, or MLA.
Okay, break that down for the non-engineers. What does MLA actually do for the end user?
In a standard transformer model, the key value cache, or KV cache, stores the context the model needs to remember. Think of it like the model's short-term working memory. In standard models, that cache grows linearly with the context length. If you have 100,000 tokens of code, that cache becomes a massive memory hog, making the model incredibly expensive and slow to run. MLA significantly compresses that cache into a latent vector. It allows them to handle massive context windows with a fraction of the memory overhead. It is like being able to fit a whole library into a single notebook without losing the details.
And that is why the pricing is so disconnected from what we see here in the States. Daniel mentioned that DeepSeek v3 costs about 27 cents per million input tokens. To put that in perspective for everyone, Claude 4.6 Opus is $5 for that same million tokens. That is nearly a 20 times difference. Is that just a loss leader strategy to gain market share, or is the architecture actually that much cheaper to run?
It is the architecture. When you combine MLA with their specific implementation of mixture of experts, which they call DeepSeek MOE, you get a model that performs at a frontier level but was trained for approximately $6 million. Most estimates for training a model of that caliber in the West start at $100 million and go up from there. DeepSeek is a subsidiary of Highflyer Quant, which is a massive quantitative hedge fund, so they approach this from a perspective of extreme mathematical efficiency. They are not just trying to build a smart chatbot, they are building a reasoning engine for high-stakes environments where every millisecond and every watt of power counts.
That reasoning aspect is key. DeepSeek R1 matched OpenAI's O1 series on the AIME 2024 benchmarks, which is basically the gold standard for mathematical reasoning. They both landed around 79%. It feels like the moat OpenAI thought they had with reinforcement learning and thinking models was crossed in record time.
And if the reports about V4 are accurate, we are about to see them pull ahead in long context coding tasks. But we should not let DeepSeek soak up all the spotlight because what Zhipu AI is doing with GLM-5 is arguably even more impressive from a systems engineering perspective. Zhipu is a spin-off from Tsinghua University and they just went public in January. Their GLM-5 model is a 744 billion parameter beast, but the most important thing about it is not the size. It is the fact that it was trained entirely on domestic Huawei Ascend chips.
That feels like a direct answer to the export controls. There was this narrative for a long time that without NVIDIA H100s or the newer B200s, Chinese labs would be stuck in the previous generation of AI. But GLM-5 scored a 77.8 on the SWE Bench verified benchmark. That is neck and neck with Anthropic's latest and greatest.
The hardware sovereignty angle cannot be overstated. By optimizing their models for the Huawei Ascend stack, Zhipu has proven that you can reach state-of-the-art performance without being tethered to the Silicon Valley supply chain. Beyond the hardware, GLM-5 is explicitly designed as a systems architect rather than a conversationalist. When we talk about agentic AI, most models are just chat boxes that have been shoehorned into using tools. GLM-5 was built from the ground up to handle multi-step software engineering workflows. It looks at a code base not as a string of text, but as a complex system of dependencies.
I love that distinction. It is the difference between an assistant who can write a function for you and an engineer who can refactor an entire repository. If I am building an agentic workflow, I do not care if the model is polite or has a personality. I want it to understand the architectural implications of a pull request.
GLM-5 actually ranks first among open weights models in the Vending Bench 2 Business Simulation, which tests high-level decision-making and resource management. It is designed to think in terms of execution. And speaking of execution, we have to talk about MiniMax and their new M2.7 model that just dropped on March 18th. They are calling it a self-evolving model.
That sounds like marketing fluff at first glance. What does self-evolving actually mean in this context? Is it just a buzzword, or is it actually doing something new?
It refers to their focus on autonomous research workflows. MiniMax was founded by Yan Zhenji, who was a vice president at SenseTime, and he has a very specific vision for AI that can perform reinforcement learning research on its own. In their internal testing and on the MLE Benchlight, which focuses on machine learning engineering tasks, M2.7 achieved a 66.6% metal rate. That puts it right there with Google's Gemini 3.1. It is specifically tuned to handle the kind of iterative trial and error work that human researchers do when they are trying to optimize a model or analyze a complex data set. It is essentially an AI that is good at building better AI.
So if DeepSeek is the mathematician and GLM is the systems architect, MiniMax is the data scientist, it is interesting how these labs are starting to specialize rather than everyone just trying to build a general purpose, everything, model. It makes the choice of which one to use much more tactical for a developer.
It really does. And then you have Moonshot AI, the creators of Kimi. Their founder, Yang Jilin, is a former Google and Meta researcher who is basically a legend in the field of long context. Kimi K 2.5, which launched on March 11th, has a 256,000 token context window, but what makes it the leader in that space is their proprietary prefix caching.
We have talked about the VectorDB hangover in episode 1215, where we looked at how expensive it is to keep retrieving data for RAG. Does Kimi's prefix caching solve that?
It changes the math entirely. Prefix caching allows the model to store the pre-processed state of a large chunk of text, like a massive legal archive or a 10,000-page codebase. When you ask a question, the model does not have to reprocess that entire context from scratch. It just jumps straight to the new information. It makes retrieval across those 256,000 tokens feel almost instant and, more importantly, makes it much cheaper for the developer. This is why Cursor was using it. If you are building a tool that needs to see your whole project at all times, you need that kind of efficient long context retrieval. You cannot wait 30 seconds for a model to read your files every time you hit save.
It is funny you mention episode 1215, because back then we were talking about how the gold rush of vector databases was hitting a wall because of the cost of scaling. If you can just stuff 250,000 tokens into a model like Kimi and have it actually work without breaking the bank, the need for complex RAG architectures starts to diminish for a lot of mid-size use cases.
The economics are shifting so fast that what was a best practice 6 months ago is now a legacy bottleneck. But we should address the elephant in the room that Daniel brought up, which is the comparison to Western state-of-the-art models. If we look at the SWE bench for software engineering, GLM5 is at 77.8 and MiniMax M2.7 is at 56.2. Claude 4.6 Opus is at 80.8 and GPT 5.3. Codex is at 92.0. So the Western models, especially the specialized coding versions of GPT 5.3, still hold a raw performance lead in pure coding.
But at what cost? That is the part that keeps coming back to me. If I am an enterprise and I'm running millions of agentic steps a day, am I going to pay 20 times more for a 5 or 10% increase in benchmark performance? Especially when the cheaper models are open weights?
That is the second major advantage beyond cost, sovereignty. When you use Claude or GPT 5.3, you are sending your data to a closed API. You have no control over the model weights, no ability to self-host, and you are subject to the safety filters and nanny layers that these companies bake in. We did a whole episode on this, episode 847, about the rise of uncensored models. DeepSeek and Zhipu provide open-weight versions of their frontier models. An enterprise can take DeepSeek v3 or GLM5 hosted on their own local hardware and know that their proprietary data never leaves their four walls.
And for a lot of companies, especially in finance or healthcare, that isn't just a nice-to-have feature, it is a requirement. If you can get near GPT-5 performance on your own servers for a fraction of the price, the moat of the San Francisco labs starts looking more like a white picket fence.
It also touches on the political worldview we often discuss. There is a real strategic necessity for sovereign AI. If you are a country or a massive corporation, you cannot afford to have your entire cognitive infrastructure dependent on the whims or the regulatory environment of a single foreign city. The fact that these Chinese models are becoming frontier class means there is now a viable alternative stack. Even if you are pro-American and want the US to lead, you have to acknowledge that the competition is no longer just copying. They are innovating on the fundamental math.
It is a bit of a wake-up call. We saw this with the Cursor incident. A US-based company, built by world-class engineers, looked at the landscape and decided that a Chinese model was the best tool for their specific job. That is a meritocratic shift. It says that the best tool wins, regardless of the passport.
It is also a licensing headache. The Cursor incident got spicy because Moonshot's license for Kimi is a modified MIT license. It requires prominent attribution if the model is being used in a high-revenue product. Cursor apparently skipped that part, which is why Yulundu was so vocal about it. It shows that these labs are starting to protect their intellectual property just as aggressively as the Western labs. They know they have something valuable. They are not just giving it away to help Western startups get rich.
So if we are looking at the big four and trying to give Daniel some practical takeaways on which one to use for what, how would you break it down?
If you are doing pure algorithmic coding, heavy math, or if you need a thinking model that can reason through complex logic, DeepSeek R1 and the upcoming V4 are your best bets. They are the closest thing we have to a peer for OpenAI's O series. If you are building agentic systems, Like a virtual software engineer or a complex business automation agent, Zhipu's GLM5 is the leader. Its systems architect design makes it much more reliable at multi-step tool use. It does not get distracted as easily as a chat-focused model.
And for the research and data side?
That is where MiniMax M2.7 shines. If you need to automate machine learning experiments or complex Office suite tasks like deep Excel modeling or multi-document analysis, their focus on self-evolving intelligence and autonomous research workflows gives them an edge. And finally, if you have a massive amount of static context, like a whole library of technical manuals or a giant codebase, and you need to query it constantly, Kimi's prefix caching is the gold standard. It will save you a fortune compared to running standard RAG against a Western API.
It feels like the era of the one model to rule them all is ending. We are moving into a world of hyper-specialized, highly efficient models where the geographic origin is becoming less important than the architectural philosophy.
We are also seeing the agentic shift we predicted in episode 1231 play out in real time. We said back then that 2026 would be the year where raw benchmarks matter less than agentic reliability. GLM5 and MiniMax M2.7 are the embodiment of that prediction. They are built for the do phase of AI, not just the chat phase. They are designed to be reliable components in a larger machine.
What I find most fascinating is the hardware angle you mentioned. If Zhipu can hit SOTA on Huawei chips, it suggests that the US strategy of chip denials might have actually accelerated the development of a completely independent and highly optimized alternative stack. It is the classic necessity is the mother of invention scenario. If you cannot buy the best chips, you have to write the best math.
It is a massive hedge against export controls. If you are a developer in a region that might face future restrictions, or if you just want to avoid the NVIDIA tax, these models prove there is a path forward. It is a more resilient ecosystem when there are multiple ways to reach the frontier. We are seeing a diversification of the entire AI supply chain, from the silicon up to the weights.
I do want to poke at one thing, though. We have talked about the advantages, but what about the risks? If an enterprise is self-hosting DeepSeek, they still have to worry about the provenance of the training data and the potential for embedded biases or even security vulnerabilities. Is that a real concern or just geopolitical FUD?
It is a legitimate concern for any open weight model, regardless of where it comes from. When you host a model, you are responsible for the output. However, because the weights are open, you can actually audit the model more effectively than you can with a closed API like GPT 5.3. You can run your own red teaming, you can apply your own fine-tuning to align it with your corporate values, and you can wrap it in your own security layers. In many ways, self-hosting an open weight model from Zhipu gives you more security control than sending your data to a black box in San Francisco, where you have zero visibility into what happens to your prompts.
That is a fair point. Transparency is a form of security in itself. You might not know exactly what went into the training set, but you can see exactly how it reacts to your specific data without a middleman watching.
And that brings us back to the VectorDB hangover we mentioned earlier. When you have these massive, efficient context windows and the ability to self-host, the entire architecture of how we build AI applications changes. You no longer need to build these fragile, complex pipelines to feed bits of information to a distant, expensive model. You can just give the model the whole context and let it work. It is a return to a simpler, more robust way of programming.
It is a much more elegant way to build. So, looking ahead to the rest of 2026, we have DeepSeek V4 on the horizon. We have the continued evolution of the Huawei hardware stack. Do you think the Western labs have a response? Or are we looking at a permanent state of parity now?
I think we're looking at a permanent state of intense competition. The AI moat that people were talking about a year ago. The idea that you needed $10 billion and 100,000 H100s to compete has been proven false. DeepSeek did it for 6 million. That means the barrier to entry for frontier-level intelligence is much lower than we thought. The response from the Western labs will likely be to lean even harder into agentic ecosystems, integration with your OS, your email, your entire digital life, where they still have a massive home field advantage.
The ecosystem moat rather than the model moat. That makes sense. If Apple or Google can bake their models into the hardware you already carry, they don't need to be 20 times cheaper. They just need to be there. But for the developers, the builders, and the enterprises who are looking at the raw utility of the intelligence, the Big Four are no longer optional. They are a core part of the toolkit.
They really are. If you are not testing your workflows against GLM-5 or DeepSeek, you are probably overpaying and underperforming. The frontier is no longer a single point on a map, it is a global distributed network of innovation.
It is a wild time to be a developer. Daniel, thanks for the prompt. This was a deep one, but I think it is one of the most important shifts we have covered this year. It really changes the perspective on where the frontier actually is.
It is not a single point on a map anymore. It is a global race.
Well, I think that is a good place to wrap this one up. We have covered the efficiency of DeepSeek, the agentic focus of Zhipu, the research autonomy of MiniMax, and the long context mastery of Kimi. The Big Four are here, and they are not just competing on price. They are competing on the fundamental way these models are built and deployed.
It is a testament to what happens when you have a massive amount of talent and a very clear set of constraints. It forces a level of innovation that you just don't see when the budget is unlimited.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a big thanks to Mo Dow for providing the GPU credits that power this show and allow us to dive into these technical topics every week.
If you want to keep up with these developments as they happen, search for My Weird Prompts on Telegram to get notified the second a new episode drops. We are also on Spotify, Apple Podcasts, and pretty much everywhere else you might be listening.
This has been My Weird Prompts. We will catch you in the next one.
See you then.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.